Just like there are different ways to set up, just like there are different ways to draw a circuit, there are also different types of circuits. Besides just learning how to draw them, we also need to learn the physical realities about how they can be set up. Our first type of circuit is simply called a series circuit. A series circuit means that we have everything in the circuit in one long chain. So we have a series of resistors. The way we like to think about this is from the perspective of a charge moving through the circuit. So if I've got a little charge here, say a little positive charge, it wants to move through the circuit in order to get to the negative side of the battery. It's going to move through these resistors in series. So how is that going to affect the total resistance of the circuit? Well, voltage is again equal to IR, that's Ohm's law, but what R are we going to use? We have R1 and R2, they're both 500. Do I put 500 here or what? Well, in a series circuit, the rule for calculating resistances when we have multiple resistors is that R total will be equal to just the addition of the resistors in series. If I had 3 resistors, I would just tack on another one here. And so the way we like to represent this law is by putting a little dot, dot, dot after this to say I could have any number of resistors, and as long as they are in series, one after another, along this conductor, along this wire, I'm just going to add all of them up to get my total resistance. So in this circuit, I only have 2. Very simply, both are 500, just to keep things nice and simple to start with. So I've got 500 ohms plus 500 ohms will be equal to 500 plus 500 is 1,000. So 1,000 ohms. It's very common because we can have so many different, such a different range of resistances. We have examples anywhere from 10 ohms, which might be a heating element in an oven, to several 100,000 ohms, which might be a resistor within a computer circuit. So whenever we have things in the thousands, it's going to be very common for us to use K ohms to say 1,000 ohms, or mega ohms when we have millions of ohms. In this case, because our components are each 500, we're going to leave it at just regular ohms. But you'll see those more in the future. So 1,000 ohms is my total resistance, and that's what I'm going to use in my Ohm's law. So as we're keeping track of our variables here, it is very common to keep track of them all just down to the left side, keeping track of my individuals and my totals. Okay? So then what is my current going to be? Well, my current is going to be equal to V equals IR, so I'm going to take my voltage divided by my resistance to get my current. My voltage of 50 divided by 1,000, and that should be simple enough to do in our heads because dividing by 1,000 is just going to move that decimal place 1, 2, 3 places. So I'm going to have 0.05 amps. Commonly, when I have less than 1 amp, instead of writing 0.05, I'm going to drop down to milliamps. So I'll have 50 milliamps. This is just metric, going from the regular amount down to milli anything. It's just moving the decimal place over 3 places. So I have 50 milliamps from 50 volts, total resistance of 1,000 ohms. Let's look at another example. In this circuit, we're asked to find the value of R3, but we're not given a total resistance. We are given voltage and current through the entire circuit. So, how do we find R3? Well, first we need to find our total resistance. We're going to use Ohm's law to find that. Remember, Ohm's law is V equals IR. In order to find R, we're going to divide both sides by the current. So I'm going to take my 120 divided by 5 milliamps. Now remember, in order to use this in Ohm's law, I need to put things in terms of amps, not milliamps, amps. To do that, I need to put my decimal place 3 places to the left. It's going to be 0.005. 120 divided by 0.005 is going to be 24,000 ohms. Now notice, my other ohms are 3 kiloohms and 10 kiloohms. That's 1,000 ohms. So 24,000 ohms would be 24 kiloohms. Okay, so total resistance is 24 k ohms. So how do I find R3? Well, remember, in a series circuit, my total resistance is equal to the addition of all of my individual resistors in series. So RT equals R1 plus R2 plus R3. R1 was 3 k ohms. R2 is 10 k ohms. R3 is what we're trying to find. All of that will be equal to 24 k ohms. So all we need to do is subtract 3 and 10 from both sides. So we're going to subtract 13 k ohms from both sides. And that'll leave us with 11 kiloohms. So the value of R3 is 11 kiloohms. So R3 right here is 11 kiloohms. There we go.